you're on mute. Okay. Okay, so memory target. Okay, so memory target is the total size, memory target total size of SGA and PGA. Okay, the total size of SGA and PGA. So if I put memory target as 10 GB, and that means 10 GB the total size of SGA and PGA, and Oracle will automatically manage within this size. So there are two parameters. One is memory target and one is memory max target. So memory target and memory max target. Now the benefit of using memory max target is, like, just assume I have put memory target as 10 GB. Okay, because I don't want to give. Okay, so 10 GB I put, and I put memory max target as 12 GB. So it it is mean that memory target is a dynamic parameter, and memory max target is not a dynamic parameter. Dynamic parameter means that I can change this parameter during the running of the database when the instance is up and the database is up. So I can change this parameter, but memory max target I cannot change. So I am putting memory max target as 12 GB and memory target as 10 GB. So it means that I have kept 12 GB for database, but right now I'm using 10 GB only, so that it can be used elsewhere, because I think so currently database doesn't require 12 GB. 10 GB is more than enough for a database, but so that other processes can take up this 2 GB, or operating system can take up this 2 GB for better performance. But somehow I don't want to take a risk. Okay, I want to take a risk. I want to keep 2 GB as a buffer in between when I use it, when the database performance is going down, or when there's more memory, more primary memory, or like you can say more size of SG and PGA. Then what I can do, I can make memory target as 12 GB on the runtime when the database is running. I can put memory target as 12 GB, and Oracle will automatically increase the size of SG and PGA according to it, according to the requirement. Okay. So generally, I told you the SGA remains 80% and PGA remains 20% of your total memory size. Okay, that is the Oracle standard, and maybe 70 to 80%, and that is 20 to 30%. You can say. Okay, so this is the difference between. But if I want to increase more than 12 GB, I cannot increase during the runtime. Okay, I need to restart my system, restart my database, or you can say restart the instance, not the database, restart the instance to make it effective. If I want to make it more than 12 GB, because memory max target is 12 GB. So if I want to make it 15 GB or 13 GB, I have to increase my memory max target. Then I have to increase my memory target to 13 GB, and then I have to restart my system. Okay. So we will study about this, what is mean by SP file, and what is this parameter says, alter system set memory target. These, just assume these are all the parameters for the database. So this is parameters of the database, or you can also you can say the parameters of the instance that is running. Okay, so now this is the command to change it. You change it with the command of alter system, and we will going to understand what we mean by scope over here. Okay, in the further slide we'll mean by scope. Now one thing is I told you SGA using memory target. Second thing is I am intelligent enough, or maybe I think that I can manage better than what Oracle is managing internally, or what Oracle is managing internally. Okay, I want to specifically give different value of SG and PGA. Okay, that I also can give. Okay, I need not to I did not leave it to Oracle to decide on the parameter, on the values of SG and PGA. I can decide on my own, on my strictly I can decide my values. Okay, because it is an additional process overhead on the Oracle also, because Oracle keep on looking at the performance of SG and PGA. When we have doing it automatically, we are leaving it to Oracle. It will add one more process into Oracle. Was one process will be there which is checking each time what should be the adequate size of SG and PG, and whether both of these pools are not facing any space crunch. Okay, so it'll keep on observing. One process would be there which keep on observing, and one process which is there which will keep on changing the values also as per the requirement. So algorithm will run in the background So you can say it's a additional overhead also to some extent, not much, but to some extent. Or maybe I think that I can manage better way, so I can explicitly set. Okay, generally we set only. Okay, we set the size of SGA and PGA till now. Okay, maybe till 11G specifically, and maybe things are getting better with each version. So maybe we can leave it to Oracle also in the future. Okay, so one is you can set it with memory target. Second thing is you set bed own. So for the PGA you have parameter which is known as the PGA aggregate target. Okay, so your parameter which says as PGA aggregate target, this is a parameter to set the size of the PGA. So you can say alter system set PGA aggregate target is equal to 2G. G stands for GB, M stands for megabytes. So you can say 2G, that is 2 GB, and similarly SGA target and SG max size. So SGA target and SG max size is the same thing which we studied in memory target and memory max target. So you can set SGA target as 8 GB, or maybe SGA target as 8 GB, and SGA max size is 12 GB or 10 GB. Okay, 8 GB and 10 GB. Similarly, sometimes if a space crunch occur, this such facility is not available in the PGA. Okay, just remember, this facility is not available in the PGA, because generally PGA we don't face any space crunch, because generally things lesser things are used. Okay, just keep it in the last stage. Data goes to the PGA and gets used for formatting or sorting kind of stuff. So, and that too can be managed with SGA also. So we generally don't face any much space crunch on that side, but sometimes we face space crunch on the SGA side. So this facility is there also. Like we can keep SGA max size as 10 GB, and we can give SGA target as 8 GB. Okay, so we can increase it anytime to 10 GB. Or we can keep it 10 GB, 12 GB, 15 GB. So we have a bandwidth that we can increase it to that level anytime during the runtime. Okay, but if we want to change this PGA parameter, we need to restart our system. Okay, so we don't have an upper limit or lower limit in this. Now we have a kind of upper limit, that is SGA max size. So it's talking about the processes. So there are different processes. We talked about user processes, or you can say server processes. So user process is a process that connects to the Oracle database. So I told you, whenever you are a user, you are making a connection to the database. So you are making a session to the database. It is known as a session to the database. So you're making a session, and when you are firing a query, you are initiating a user process. Okay, you are initiating a user process for that user process associates with the server process in the database itself, and user process gives your query to the database server, and then server process internally do all kind of stuff. It takes the query to different pools, as we discussed: dictionary cache, shared pool, buffer cache, and then give the result back to the user process, and user process give back to the data. So every time you're firing a query, you are initiating one process. You're initiating one user process. Okay, you are initiating one user process. Okay. Now user process, now come database processes. Database process, first is the server process, and second is background process. So server process, the same process which I told you. When user process initiates, it connects to it sends the data to the server process. So there are multiple server processes which is handling user processes. Okay, just assume 100 people are connected to the database and execute a query. So there would be 100 user process. Okay, so there would be 100. Let me open the document again. Okay, so there would be 100 user process at a time which sends the data, or you can say send the query. Now this 100 process, to handle this query, there would be server process in the target, or you can not target, you can say database. So there would be server process in the database. So there can be any number of server process, maybe 5 or 10, depending. Oracle is deciding internally. Okay, so Oracle database is deciding internally. So it might initiate 10. Okay, Oracle thinks 10 is sufficient to handle 100 processes. So it will take 10 processes. It takes this query and sends it to different pools, manages all the things, and then returns the query back to the user process. Okay, so server process is the at the server end, at the database server end, and it's taking up the query and then giving it back to the user process, to returning the result back to the user process. Okay, so we don't have any any particular name associated with it. We just call it as server process and the user process. Okay. So as things are keep on increasing, as things, as just assume there are a lot of users that are connecting, so there will be different processes. Okay. But this user process, it does not does not initiating in the server itself. Okay. So these user process, just don't think that if there are 100 user processes, the load on the database is more. No, load of the database is more when there's more server processes. Okay. But if Oracle is not, if just assume the 10 is not able to handle 100 processes, so Oracle will automatically increase these server processes. Oracle will make it 15, 20, 30, 40, or but generally one server process handles like many user processes. It's not a ratio of 1 to 1. It is not 1 to 1. In some cases, like you give a command like shut down the database, or you give a command like changing any structure to the database, then it is 1 to 1. Then is a dedicated connection. But generally is a shared connection. So shared connection means multiple they are one server process handling multiple sessions. Okay. Just to reduce the memory usage on the database server end, just assume there are thousands of query firing on the database, right, across, let's assume a railways network, or when you're booking a flight or something. So if for each session Oracle will produce one use server process, that is a lot of burden on the database. Okay. And moreover, everything is taking time. Okay. Everything is taking time. Now assume you put a query to book a ticket. I don't know how you book the ticket in an Indian railway site, how often you do it, or you done it or not. Okay, that is a different thing. But whenever you book it, whenever I booked it, takes a lot of time. You put a query, you put a query to select the availability, and availability itself take 1 or 2 minutes, right, to give you the availability. So for what, for 1 or 2 minutes, what the server process will do? It will sitting idle, because it has given the query in the shared pool to make a parse tree. Then it is giving the query to the buffer cache to get the data from the disk. So for that few seconds, what is doing? Nothing. It's putting sitting idle. So in that few seconds, what it can do, it can serve another process, another user process, or it can serve, or you can say another user process, or you can say it can serve another query, right? So it can serve another query during that time, because it's actually just pushing the things from here to here. Okay. Like in an office, there's a one peon which is putting the file from one of one block to the another block, or one to another. It's moving ahead the file from here to here, here to here, here to here. The same way server process is also putting it is putting the query to the shared pool, then taking it to the buffer cache for the data, then to the PGA. But in between it has no work. So it is sitting idle to some time, for a lot of time. So for that time it can handle other processes. Okay. So in this way there can be shared connections where okay, so it's a lot of internal things I'm talking about. So otherwise for some cases you have a dedicated also. It's not that every time you have a shared. Sometimes user process connects to only one server process, and one server process handling that session. Okay. Generally when you are making a connection as a DBA, as a sysdba, you can say generally the connection is dedicated. Okay. So we'll go through that also in the future, how a dedicated connection is made, and how a shared connection is made, and how you will get to know which your session is dedicated or shared. You can also come to know your session is dedicated or shared. Okay. So so background processes. Okay, background processes are the process that are kind of mandatory processes we talked about in the past. I told you that they are processes which is writing the data from redo-log buffer to redo-log files. So they are processes which is not bringing the data, which is generally writing the data. Okay, so whenever you're making any changes to the database, like you're updating, you're deleting, so you're not doing directly to the disk. You're doing it in the cache only, right? You're bringing the data to the cache, then you are updating it. So somebody would write the data back to the disk, right? The update is made, but the update is made on the cache, not on the disk. Okay. So the update is made on the cache and not on the disk. So some process would be there which is pushing the data back to the disk, or which is saving the data back to the disk. Similarly in the redo log buffers also, and you are writing the data on the buffer, because this is the fast way to write. This is the fast way to do. You cannot go and make changes on the disk. They first go in this way. It's like all the things, like the concept of database goes off because it will very slow. So all the changes are made on the buffer only, on the cache only, on the primary memory, on the instance, and this slowly and steadily getting saved on the disk. Okay, after maybe 3 seconds, there are different I think triggers when it saves after 3 seconds, maybe, or after some trigger or something. Okay, maybe we can assume 3 seconds. So it is pushing the data back to the disk or saving the data back to the disk. So that is done by some processes. These processes are known as the background processes. Okay, so in addition to this, there are other processes also which is handling different things, like PMON process, that's a process monitor. So process monitor is cleaning up all the failed processes, cleaning up all the junk data from the buffer cache. There are a lot of processes that are there in the database which is doing a lot of other stuffs. We'll study about this. So dedicated connection, a shared connection. I told you about dedicated connection. When a user process is associated with one server process, that is a dedicated connection. Okay. For each session, the database application is run by a user process that is shared by a dedicated, that is served by, not shared, served by a dedicated server process that executes Oracle database server node. So there is one user process connects to one server process. That is a dedicated connection. Okay. That is always a dedicated connection. Shared is when we have one server process that is serving multiple network connections, or multiple, you can say, saying multiple network session requests, or you can say multiple user processes or multiple queries. That the query is also coming through network, right? So you have different words to say, express or say, because it is connecting through a network, the sessions are coming through. So that is a shared. Okay. So this is about server process we already discussed. Let's go through that. So Oracle database creates server process to handle the request of the user processes connecting to the instance. The user process represents the application or tool that connects to the Oracle database. So it may be on the same machine as Oracle database, or it may be on the existing remote client and use a network to reach the Oracle database. Okay, so it is same we discussed. So Oracle database creates server process to handle the request of the user processes. Okay, the user process communicates to the listener, the server process. We discuss all these things. So what does the server process is doing? It is running the SQL, parsing and running the SQL statement through this application, read necessary blocks from the buffer cache and from the shared buffer cache of the SGA, returns result in such a way that the application can process the information. So it is doing all the internal stuff. I told you, taking the file or taking the query to one block to another block, to one pool to the another pool. So it is moving the query and giving the result back to the user process. So these are all long list of the background processes. Okay, so these are all the long list of background process, what all they're doing: database writer, log writer, checkpoint process, system monitor, process monitor. So these are all the list of the background processes. Let us go through this. Okay, so these are all the processes. Okay, and background processes: database writer, log writer, checkpoint process, system monitor. Let's go through them quickly, and then you can maybe you can go through back to the slides, and then you can come back with your questions. Okay, so database writers. Database writer, what database writer is doing? Database writer is the link between the database buffer cache and data files. Okay, so whenever you're making any changes to the buffer cache, okay, so that changes need to go back to the disk finally, because everything need to be saved on the disk. So that is the link between buffer cache and disk. So now there should be some trigger when it should write. Okay, there should be some system when should write. So when should write, if there's a trigger which is known as a checkpoint. So checkpoint is a trigger when it get initiated. Database buffer cache, what all blocks are there which is not written. Okay, these blocks are known as the dirty blocks. Okay, these are known as the dirty blocks or modified blocks. So all these blocks are written back to the disk. I told you earlier as well that the things changes, things, everything is done on the basis of blocks, not on the basis of row. Okay, just assume Oracle needs one row in one particular block. So it will bring the complete block into the buffer cache. That block might contain 4 or 5 rows, but it is bringing all that 5 rows into that buffer cache. It might needs only 1 row out of that 5 rows in that block, but it has to bring all the complete block. There is no option because it doesn't works on the row level. It works on the block levels. So that the complete blocks come into the buffer cache. That block might contain 5 rows, 10 rows, 15 rows, or 50 rows also, depending on the size of each row. Okay. So that all complete block come into here. But now when you make any changes to that block is completely go back and will override into that block. Maybe it's only one single change. Maybe just an salary change from 100 to 150, or employee address is changed. Okay, one row is changed, but that will completely override into that block which is there on the disk. Okay, so this is the way it works. This is the internal mechanism or internal architecture it works. So each block has an address. So is assumed that this block is changed, this address is changed, that so this block is changed. We'll take that block and go back to and overwrite on the disk. Okay, so the instance is the latest version, that has the older version, so it'll go and write back to the disk. So the architecture is changing every day. So I'm talking about 11G and 12C. In the future, it might go to that extent. It has already gone to that extent, I told you. And it's already in the development phase that now things will move into the row level rather than block level. Okay. So, but I don't want to discuss in that scenarios because it's still not uh, it 11G and 12C, the basic architecture on the basic hardware. This is the terminology, or this is the way it works, Oracle works. Okay, so the checkpoint is the trigger which get initiated. Now that trigger has that then the question would be in your mind that when this trigger will be executed. Okay, so this trigger or checkpoint would be executed depending on a parameter. Okay, depending on the parameter, there's a parameter set for this checkpoint, and then it will be initiated. When it is initiated, then the buffers, all the dirty buffers are going back to the disk. So when that dirty buffers are written to the disk, these buffers become, you can say, uh, the flag of that buffer changes. Maybe the flag is 1, then becomes 0. So you can anytime override those buffers. So the checkpoint executed based on the parameter, I told you that checkpoint is executed based on parameter and lot of other things. Okay, like when just assume when there are a lot of the there are a lot of the disk, the buffer cache is almost full. There are a lot of dirty buffers that they're in the buffer cache, and Oracle thinks that, but like Oracle internally has algorithms which really thinks that if the instance crashes, then what will happen? Because if the instance crashes or the RAM crashes, what will happen? These all the blocks which are written over here on the disk and which is on the buffer, which is not written to the disk. So there's a risk, right? It's always a risk. Okay, so that to minimize that time to recovery, if the instance crashes, the checkpoints are executed very frequently. Okay, maybe 3 seconds or 4 seconds or 5 seconds. Okay, in general, depending on the changes is made to the disk. The database is sitting idle for hours and hours, for days, so that means no changes are made to the database, or you are putting just select queries, then there is no point of executing the checkpoint. Okay, frequently. But these all things are internal things, right? We have we can manage this. We can manage the checkpoint. We can set some time of the checkpoint. Definitely we can do it, but it's better to give leave it to Oracle. Okay, so we can set default values, which is actually the best optimum values, and for these things, and Oracle will automatically manage this. But maybe, but we have a right to do it because as a DB we have right to change these values also. Now comes the log writers. Log writers are writing from the log buffer to log disk. Log files. I told you what log buffer is. What a log is. Log are the changes are made to the database. So it is writing to the log disk. So it is also writing on the base of some conditions. Okay. What are those conditions are? Okay, so it's writing first of all is it is writing at the time of every commit. Whenever you are committing, when you're executing commit on your database, you are typing commit. You know what is commit is, right? When you are typing commit on the database, then log buffer pushes the data to the log files. First thing is that. Second thing is when the log buffer is itself 1/3 full. Okay, and every 3 seconds. Okay, so every 3 seconds it writes. 3 seconds is the kind of so as you can say 3 seconds of time after everything it writes, and it can write in between 3 seconds also in case it assumes that log buffer becomes 1/3 full. So it doesn't want to take a risk. Once it is 1/3 full also, it will go and write. Okay, and every commit. Okay, so these are three things when to write. When a user process commits a transaction, when an online redo log switch occurs. Online redo log switch. Okay, I have not told you about this. Maybe we can discuss in the future about the redo log switch. When the redo log buffer is 1/3 full, when a database writer signals before a database process writes, when 3 seconds have passed since the last writer, and redo log buffer is okay. This is I think the wrong thing. Okay, so this is the line. One thing is when the database writer also writes. When the database writer is writing to the database files, then just before the database writer writes to the data files, it will also ask the log writer to write on the log files. Okay, so there are a lot of things now you tell. One is commit, one is 1/3 full, one is 3 seconds, and one is when the database writer is writing to the data files. So log buffer writes more frequently than the database writer to the database files. So there are a lot of conditions which is more there in the log buffer, because log buffer is automatically is very small, and once the data is goes to the log files, the data becomes very secure now. So secure means now even if because the changes are already there in the log files, right? What changes are made, so you know that it is saved. Now even if the instance crashes, you can get the changes from the log files. Okay, even the data is not refreshed in the data files. Right, even the instance crashes and commit has occurred and the instance is crashed, what will happen? The data is saved because commit will only occur if the database is written to the log files. Now just assume log file is not there or log file is corrupt, the storage, commit will not occur. Okay, because it cannot risk the data. The data is in the risk. Commit means the end of the transaction or saving of the transaction. Right, so commit is the saving the transaction. So just assume we are committing and the log files are not there or log files are corrupt. Commit will not occur, it will hang. It will hang the database. It will not occur. It will give the error in the alert log file, in the log file of the database, but it will not commit because it's when the log files are not there, it is not guarantee of saving of the database. What will happen if the database crashes at that time and commit occurred? So data is lost. So it cannot risk the data integrity. So commit occur means the end of the transaction. End of the transaction means saving the transaction. So data is saved in the log files. Assume after commit, database crashes. Database buffer was about to write to the data files, but before writing the data files, database crashes. So what will happen? Now Oracle will automatically get the data from the log files. It will know that which was the old data, which is the new data. It will refresh the data into the data files. It will take time when it is starting next time. It will take time. When you give the startup command, it will take time to start because before starting, it will recover the data. It will make the data in sync. Okay, because you get to know the database was crashed. It was not a normal stop. It was something happened to the machine. The instance crashes. Database buffers was not able to write to the data files. So you'll get the data from the log files and it will refresh the data. Okay, so this is there. So now checkpoint. Checkpoint I told you. Checkpoint is a trigger. Checkpoints are trigger that is occur in the database depending on different conditions, depending on different conditions you can say. So what does the checkpoint occur? What does the checkpoint does? One thing is checkpoint gives a signal to the database writer to write to the data files. It also writes to the control file and each data file header. Okay, so it writes to the control file and each data file header. We'll study about what the control file is and data files are. Definitely we'll study about it, then let you know. Okay, so writes to the control file and writes to the data files headers also. Now come the smon, pmon and archive. So smon performs an instance recovery. Okay, cleans up unused memory sample segments. So all the unused things are cleaned up. Recovery, I told you how the recovery occurs. Assume that database write commit occurs, data is written to the log file, but it does not return to the data files. So if the crash occurs, then what it will do, it will get the data from the redo log files, get the data from the redo log files, and will refresh the data files. So who is doing it? SMON is doing it. Okay, system monitor has the responsibility to do it. Okay. Process monitor is another thing which is managing all the processes, perform process recovery when the process fails, cleans up the database buffer cache, frees resources that are used by server processes, monitor session for idle session time. So it is managing all the process, other processes, viewer process, server process. So it's managing all the failed process, cleaning up all the memories, archive files. The archive process is writing into the archive files. So from the redo log files, there's a copy of the redo log file is made, which is written to the archive files. Now the writing from the redo log files to archive files is done by the archive process. Okay, so these are all the major processes which we have done. One is the recover process. Recover process is the recovery process. Now, in case one recovery was which is done by SMOM, that is a crash recovery. If the instance crashes, machine crashes, so that recovery is done automatically by Oracle. One thing is storage crashes. If the storage of the database crashes, all the data files, some data files is lost, some control file is lost, or some major files of database is lost due to the storage issues, then the recovery is done by the recoverer process. Okay. Now this recoverer process uh, is now this recovery is done manually, not automatically by Oracle. So this is done manually by Oracle, manually by us, by the DBS. So another is the listener registration process. Listener will study about the listener also in the networking sessions. Registers information about the database instance dispatcher process with Oracle Net Listener. So now name of the listener denotes listener, that is listening. Okay, what does it listening? It is listening all the connections which are made to the database. So it is this process which is there which is running on the database server, that is listening all the connections. It is trying to make the connection to the database. It is storing the information on the database with the database is what is the machine address, what is the machine name, what is the port number, and what is the instance name, port number. So everything is there in the listener. Okay, so listener is making a connection to the database. So all the connections which are made from the clients, from the Oracle clients to different applications, JDBC, uh, or maybe TNS clients we have. So different clients or Oracle SQL clients or any application which is connecting through JDBC or through Oracle clients. All the clients go to the listener first. Then this listener makes a connection to the database. So the listener is a process which can manage multiple databases. It's not like one listener is listening only for one database. Listener can listen for multiple databases also. Okay. So when the application is connecting to a database, it is not connecting to directly connected to database. It's going through a listener. Okay. It will provide the machine name, instance name, database name, and the listener port number. Okay, it will connect to the machine name and the port number, so it will make a connection to the listener. Now listener will take the database name and the instance name and will redirect it to a instance. So once connection is made, now listener comes out of the loop. It does a handshake, a kind of a handshake. Just assume when you I don't you have not worked actually. If you have worked, you know what's the role of a HR in a company. HR, your first day, your HR will come and will take you to your manager. Okay, that is take your manager. He does a handshake with your manager. Now she's out of picture, or he or she is out of picture. She doesn't know you in some case. Most of the cases in the company, So you don't know about your HR and HR doesn't know about you. The same way listener is a work as a HR also in the company, kind of HR. Okay, as a recruiter, we're not talking about all the HRs, but recruiting HR. So person who is recruiting you in a company, or you can say when an admission, you go for admission. So you go to different consultancies for admissions. Okay, or the people who are taking the admission. So once you enter into the college, you're connected to the college. You don't know about your, like, you do forget about who the consultant who take you to. They don't have any responsibility for anything. Same with listener also. Listener is on that machine listening on a particular port number, so that user will provide the port number. So user say, the listener say, yeah, he has come to the right place, I am the listener, okay, for this database. He provides which database he want to connect to. Okay, maybe sometimes the instance also. Okay, so instance name also, like, so it'll maybe in case of there are multiple instances, like we have rack, right? So maybe not an instance, if it's single, then instance is not required. So it connects, it provides database name, it will take to the database, do a handshake. Now the user is connected to the database. Now listener comes out of the picture. That's it. So even if the listener is down after that, no problems, it is connected to the database. But now next time the connection breaks, now if the connection breaks, and if it have to connect again, then he needs a listener again. So that listener process is registering all the database into it, into the listener. So that process, listener registration process. So it registers the database into that listener. Okay, it registers the database into the listener. It registers all the dispatcher process. Dispatcher we talked about in case of shared server process, right? I told you about that. That there the server process handles multiple user processes, right? So to handle this, there is an additional process in the dispatcher. Okay, not going to that details yet, just you need to understand some of the terms. Okay, okay, maybe right now we cannot go because everything is interlinked and everything will come back actually. Dispatcher process, listener, archive process. So if you understand, yeah, if you want to, if you can link the things, then it's also fine as of now, because everything will come in the detail in the later chapter. Everything is like a listener or network configuration, a different chapter, different topic. Okay. And archive also you will go into very details during the recovery, when you will study about backup and recovery. So you will understand more about what is the redo log file, how does it works internally, how it works with the archive files. Even if you link some of the things, that is also fine as of now. Okay, so this is like registering of the listener. I think we already got through. So maybe we'll not go through this grid structure right now. This is more confusing. We'll go to the database storage architecture.